Hello everyone. This tutorial will be about explaining two important definitions related to the high voltage branch and specifically related to the insulator itself. These two concepts or these two definitions are the breakdown or dielectric strength. First, let's understand what is breakdown. When subjected to a high enough voltage, insulators suffer from the phenomena which is called electric breakdown. To understand this phenomena, let's take this configuration. This configuration consists of two conducting plates, the upper conducting plate and lower conducting plate. The upper conducting plate is subjected to high voltage and the lower conducting plate is grounded, so it has zero voltage. Also, we have the insulator, which is between the two conducting plates to isolate between the high voltage plate and the earthed plate. Also, we have the separation between two plates is D. If the upper plate is subjected to high voltage and the conducting plate is earthed, an electric field will flow from the high voltage plate to the ground as we saw. This is the electric field. So the insulator here is subjected to the electric field. This is another view of this configuration. Here we have the upper plate and here we have the lower plate, which is earthed, and the separation between them is the insulator, and the electric field flows from the high voltage plate to the grounded plate. So what will happen? For the parallel plates configuration, the electric field is given by this formula. The electric field equals to the voltage V over the separation D, where E is the electric field inside the insulator and V is the voltage between the plates, which is high voltage of course, and D is the separation between the plates or the insulation thickness. When the electric field applied across the insulator exceeds the threshold breakdown field for that insulator, the insulator suddenly loses its insulating properties and turns into a conductor. So when the insulator is subjected to a very high voltage or a very high electric field, the insulator will lose its insulating properties and turns into a conductor. Thus, very high short circuit currents flow through the insulator and hence breakdown occurs. So this is the phenomena of breakdown, which is the insulator will lose its insulating properties and turns into conductor and short circuit currents occur. Threshold breakdown field is constant for the insulator and it's called dielectric strength. So what is the second definition? Dielectric strength. It is the maximum electrical field or electrical stress which a given insulation will withstand without undergoing breakdown and losing insulating properties. So it's very important to know the dielectric strength of the insulator to prevent the breakdown of this insulator. Dielectric strength of the insulator is an intrinsic property of it, and it's independent of the configuration of the insulator or the electrodes with which the field is applied. So it's a special property for a given insulator. The unit of the dielectric strength is kilovolt per centimeter, as it depends on the voltage between the two plates and the separation between the two plates. Example, the dielectric strength of the air is 30 kilovolt per centimeter. So if the electric field which is subjected to the air exceeds this value, 30 kilovolt per centimeter, the breakdown of air is happening. Also, this value is at standard temperature and pressure, which is 25 Celsius and 1 atmospheric pressure. Dielectric strength is determined by high voltage tests on insulation samples to ensure preventing breakdown of the insulator. The insulator should be tested to determine the dielectric strength of it. Now, what are the factors affecting dielectric strength? There are many factors affecting this value. The first is the insulation thickness. The dielectric strength decreases with increased insulation thickness, which is the separation between the two plates. Also, dielectric strength decreases with increased operating temperature. As the temperature increases, the dielectric strength decreases. Also, it decreases with increased frequency. For gases, for gases insulation, it increases, the dielectric strength increases with pressure according to Paschen's law. So, what is Paschen's law? Here, Paschen's law shows the relation between the breakdown voltage in the vertical axis and the gas pressure in the horizontal axis. It's obvious that when the gas pressure increases, the breakdown voltage decreases until a specified point. After exceeding this point, when gas pressure increases, the breakdown voltage also increases according to Paschen's law. So there are very important factors affecting dielectric strength. So high voltage tests should be performed on the insulation to determine the dielectric strength of the insulator and ensure avoiding the breakdown of the insulator when it is used mainly in the electric power system. So thank you for your listening and see you in the next lectures.